Hello everyone. For this tutorial video, I'd like to explain how sculpting works, as well as other tools besides sculpting to edit the topology of the model. Sculpting is very similar to modeling, except it uses a brush to affect multiple vertices at once, instead of customizing the vertices in a step-by-step manner the way traditional modeling does. Although this does mean you get less precision than traditional modeling techniques, the trade-off is that it can be quicker and convenient for many people. Because of the fact sculpting is based off of vertices, having a low vertice object such as a cube is not a very good example of how to demonstrate the sculpting tools. So I will use a sphere instead, like so. The first option is called draw. And it simply allows you to draw on the vertices within the brush's range, like so. The next option, draw sharp, is basically a sharper version of draw, except there's no difference besides that. The next option, clay, allows you to sculpt the model as if you were putting your thumb in clay. The next option, clay strips, is similar to clay, except it is narrower than the traditional clay, so it's used for small strips. The next option, clay thumb, is even more precise, and is also stronger on the narrow area it affects, as if you were slamming your thumb into the clay. The next option, layer, is sort of like draw, while the next option, inflate, is very different and allows you to extend the group of vertices like a blob or spear. The next option, blob, can be thought of as a sort of extreme version of inflate. The next option, crease, can be thought of as a sort of subtle version of the clay thumb. The next option, smooth, means that it lets you smooth out the surface. The next option, flatten, makes you flatten the surface, like so. The next option, fill, allows you to fill in any indents. The next option, scrape, is sort of the opposite of fill. It creates indents rather than fills them. The next option, multi-plane scrape, I believe is not useful because scrape already does almost all of its things, so I will skip it. While the next option, pinch, allows you to pinch in the topology, like so. The next option, grab, is sort of like pinch, except you pinch it out rather than pinch it in. The next option, elastic deform, is similar, except it deforms the whole region around whatever you're selecting, rather than just whatever you are selecting, period. The next option, Snake Hook, is more sophisticated, which sort of creates a snake or spiral shape with whatever you select. The next option, Thumb, creates a sort of thumb from whatever your region is. The next option, Pose, is not useful without a skeleton system, which I am not teaching in this video. The next option, Nudge, I do not believe is actually useful because it does things that are already done by other tools. While the next tool, Rotate, simply rotates whatever region you selected. The next option, Slide Relax, doesn't do anything already covered by other tools. And the Boundary tool doesn't seem to do anything useful either. The Cloth tool essentially makes whatever region you select behave like a cloth physically. And the next tool, Simplify, doesn't seem to do anything useful. The next tool, Mask, creates a mask over whatever your selection is, which simply means a hidden extra layer on top that is used for editing. The next option, Multi-Res Displacement Eraser, doesn't actually seem to do anything useful. And the next tool, Multi-Res Displacement Smear, also has that problem. The next tool, Draw Face Sets, simply highlights the set of faces on the object for you. And the next tool, Box Mask, makes a mask based on a box selection, while the next tool, Box Hide, hides the topology based on a box selection. The next tool, Box Face Set, adds a face set within the box selection. The next tool, Box Trim, trims or deletes the topology altogether instead of simply hiding it. And the next tool, Line Project, projects the geometry onto a plane defined by a line you drag. The next tool, Mesh Filter, applies a filter to modify the entire mesh rather than simply the region you select with a brush. The next tool, Cloth Filter, also applies to the entire mesh at once and makes it behave like a cloth. The next tool, Edit Face Set, edits the face set you select. And the final tools carry over from the basic layout. Since we are editing the topology now, I believe it would be useful to point out now that not only sculpting, but many of the modeling tools shown in the previous video allow you to fine-tune their numbers in order to create more precise results. And I will show you exactly how to do this for each tool now. When you click Draw again, you will see on the right hand side a Brush Settings menu. with an option for the radius unit, which means the brush size relative to the view of the scene. The strength of the brush, or how severely the effect is applied. The direction, either inward relative to its current direction, which is marked add, or opposite relative to its default direction, which is marked subtract. The normal radius, which means the sampling radius for all of the faces that are perpendicular to the brush. The hardness, which refers to how smooth the fall-off of the brush is, or how quickly the effect fades out from the center of the radius. Auto-smoothing, or the amount of smoothing done automatically by the software for you. And there is also more advanced and detailed submenus when you click on their respective arrows. However, many of the options in the advanced menus do not get used in many practical applications of Blender, so I will ignore those. When you click on the other sculpting options, you will see the brush works in basically the same exact way. Although sometimes, on some of the options, you'll see plane offset and plane trim, which refers to the 2D plane on which the brush acts either toward or away from the surface. And plane trim simply refers to trimming the plane. Now that I've given a brief overview of how the sculpting tools work, including an explanation of how to customize the brushes, I can explain how to fine-tune the modeling options as well as to create object options to make more precise topology, like so. The basic options that you see from the layout menu do not do anything that you do not already know, as I do not have customization menus period. But the modeling options, as well as the add new object options, do have customizations, which I will explain now. With the extrude region, you will see once you have finished doing an extrusion, you will get a customization menu where you can flip the normals, dissolve orthogonal edges, customize the exact directions you extrude in all 3 dimensions, determine which axis counts as orthogonal, and change the orientation the extrusion goes by default. There is also a proportional editing checkbox you will see on all of the tools, but I would recommend not doing it and doing it manually instead, so that way your topology is as precise as you want it. The inset option has a checkbox for insetting the boundaries of the face, scaling the offset to give even thickness, scaling the offset by surrounding geometry, insetting the region along existing edges, controlling how thick the inset is, controlling the 3D depth of the inset, which is different from how thick or strong it is. turning it into an outset rather than an inset, so basically inverting the effect. Select the inset faces automatically. Make it so that each face individually is inset in your selection. And finally, an option to interpolate or blend the face across the inset, which simply means lay the computer, make it smooth for you. The customizations for the bevel menu are change whether it bevels the vertices or the edges, the method for calculating the size of the bevel once it is done, the width or strength of the bevel, the amount of segments for the bevel, the profile or shape topology of the bevel, the material that you use for the beveled faces, where the default -1 means resort to the adjacent faces for reference. Harden the normals, which means match the new faces to adjacent faces, prevent overlap of beveled edges versus old edges, loop slide, which means prefer sliding along to even widths, mark the beveled edges as seams or sharp, which I will explain what those mean later. The pattern for the bevel, the type of intersection, the strength of the face, and finally the profile type, or how the algorithm determines the shape of the bevel for you. There is only one automatic option called Super Ellipse, and the other option is Custom, where you determine the profile from the ground up. Like so. The next option, Loop Cut, allows you to determine the actual number of cuts, the smoothness of the model around each cut, the fall off around each cut, the factor or how strong the cuts are, whether the cuts are even or not, whether you flip between the edges of the cut or not, clamp the cuts within the edge, and finally, correct the UV coordinates of the 2D texture automatically, which I will explain more in depth what that means in my next video. The spin option allows you to customize it as the number of steps, whether you want to use duplicates or not, the angle of the spin, whether you want to automatically merge the first and last parts when the angle is 360 degrees, whether you want to flip the normals or not, customize the center of the spin in all three directions, and determine the direction of the spin in all three directions. The next option, edge slide. Allows you to determine the factor the sliding is done by, aka the position of the slide, whether it is even or not, whether it is flipped or not, clamp the slide within the edge, and correct the UV coordinates automatically for the 2D texture. Finally, when you add the objects, you can customize their topology automatically, like so. For a cube, you can change its size, whether you want to create a UV map by default, the alignment of the object, the position of the object in all three directions, and the rotation of the object in all three directions. For adding the plane, you have all the same exact options as a cube, so size, whether it has a UV map by default, its alignment, its location, and its rotation. For a circle, however, it is more complicated, as meshes are calculated using polygons and vertices explicitly. They never use actual curves, unlike a real-life circle. So you will be asked to customize the amount of vertices used to approximate the circle. The more the better the approximation, but also the more computationally expensive it is. The radius of the circle, the fill type for inside the circle, whether you generate a UV map by default, its alignment, its location, and its rotation. To add a UV sphere, you are asked the number of segments, which means the number of times it rotates like this. The rings, which means the number of layers it has from top to bottom. The radius, which simply determines the overall size of it, whether you generate a UV map automatically, its alignment, its location, and its rotation. For the icosphere, you will get the number of subdivisions or sections used to calculate the icosphere, the radius of the icosphere, whether it generates a UV map automatically, its alignment, its location, and its rotation. For the cylinder, you will get the number of vertices used to approximate the circle part, the radius, the depth or how tall the cylinder is, the fill type for the circular caps, whether you generate a UV or not, its alignment, its location, and its rotation. For a cone, you will get the number of vertices used to approximate the curved part, its first radius, or the bottom part, its second radius, or the top part, the depth or how tall it is, the fill type for the bases on either end, whether to generate UVs automatically, its alignment, its location, and its rotation. For the torus, you will get the number of major segments or segments of the ring rotating around the center, its minor segments or the amount of layers from top to bottom, the dimensions mode determining whether you do it major versus minor or exterior versus interior. If you choose major versus minor, major radius determines the radius of the ring overall. Minor radius determines the thickness of the ring part without the hole. If you do it exterior versus interior, the exterior radius determines the thickness of the ring besides the hole. The interior radius determines the size of the hole. Generate UVs automatically, its alignment, its location, and its rotation. For grid, you will get the number of subdivisions or sections in the X direction, the number of subdivisions in the Y direction, the overall size of it ignoring the subdivisions, whether you generate the UV automatically or not, its alignment, its location, and its rotation. Finally, for the Blender monkey, you will be asked to determine its size, whether to generate a UV map automatically or not, its alignment, its location, and its rotation. It sadly does not allow you to customize its topology in greater detail than that, however, because of the way the Blender team made it as their mascot specifically. Now that I've explained how to customize the topology of your model using all of the tools provided for you in the previous videos, as well as using the sculpting tools, I can transition toward creating a 2D texture next, which is called UV editing, because X, Y, and Z are used for the dimensions of the 3D object instead. So you use U and V as an alternative way of saying X and Y. See you then.